Alright, so in this video we're going to talk about how to multiply and divide using exponents. When you're doing these, I want you guys to remember an old skill we talked about when we first learned how to solve equations by doing inverse operations. For example, as a brief reminder, if we had 2x equals 10, we would solve this by canceling the times 2 right here by dividing both sides by 2. The idea that I want you to focus on is the fact that these canceled. Multiplying by 2 and dividing by 2, they undo each other, so they cancel each other out. There's no reason to do both. It doesn't accomplish anything. So what that equals doesn't matter, but I want to focus on the concept of when you multiply and divide by the same thing, they cancel each other out. We're going to use that when talking about exponents, especially with dividing. So remember that skill. In each of these questions that we have, we're not talking about what they equal, we're talking about how to simplify them. I'm not concerned with what the actual answer is. I don't care what x equals. What you're doing in each of these is just how to simplify it to make it look more simple, so that if you did have a value for x, you could actually use it in order to evaluate the question then. But we are not going to see what they equal. We're just going to find out how to simplify them and make them as simple as possible. Alright, so we're going to start with multiplying on the left. That's the easier of the two. We're going to talk about multiplying and dividing. When you multiply, it's one thing. When you divide, it's the opposite. That's essentially what we're going to talk about. We'll start with some very simple questions, like how to answer questions like this. Before I do, I want to talk about some literal examples. So right below that, I'm going to write that slightly differently. Let's write that as 2 squared times, let's keep it as 2's. 2 squared, so 2 to the second power times 2 to the third power. If we have that, we want to see what that equals. I know you could find out that 2 squared is 4, 2 to the third power is 8. I know you could do that, but let's pretend we didn't have the ability to see what these equaled. We're just going to simplify them. So 2 to the second power, that really means 2 times 2. So that equals 2 times 2 on the left side. And on the right side, 2 to the third power, that means 2 times itself, but there's 3 of them. So now it's a times in between, so it's times in between right there. So now when you look at it all together, you have a total of 1, 2, 3, 4. You have a total of 5 2's. So at this point, we don't care what it equals. We're going to leave it as an exponent. So that means that equals 2 to the 5th power. So, because after we multiply, there was a total of 5 of them. And to the first one, we're going to learn a shortcut. We're going to realize when you multiply things together that have exponents, this all equal 2 to the 5th power. Well, hey, look at this exponent. It's a 2, and this one's a 3. It's not a coincidence that if you had also added those together, you would have gotten the exact same answer and saved yourself time to have to write them all out like this. So this idea of when you multiply with exponents, you're welcome to write it out the long way. This is kind of like the visual approach to doing it, because you never actually have to calculate any of it. You just have to simplify it. And now we're going to do the example right above it. So let's use that property. First we'll do this example right above it. We'll do it the long way, but then we'll actually do it using the rule and see if it makes sense as well. So x squared, or x to the second power, that means x times x. That means we have 2 x's for that one. Now x to the third power, that means we have 3 x's all being multiplied by each other. And there's a multiply in between them. So grand total, we have x times x times x times x times x. That's a grand total of 5 x's. So that means x to the 5th power. So that's the final simplified answer of that question at the top. So I want you guys to realize it was the same thing we just did down here. It was just using letters. And when you have letters, you don't have a choice but to do it this way and put it as exponents. Whereas with the numbers, yes, technically you could find out what is 2 times 2 times 2 5 times. And you could do that. But we're concerned with just simplifying the exponent skills. And sometimes, especially with really large numbers, it allows you to simplify those questions, make them easier to solve or easier to use without having to do giant, scary calculations. So the rule is, it's called the product property of powers. Because remember, this is called your base. This is called your exponent. Combined, they are a power. So the product, meaning multiply, property of powers tells us when multiplying, you add the exponents. So when multiplying like bases, meaning the bases are x, they have the same base, and here the base was 2, they were the same. When multiplying like bases, add the exponents. That's essentially what it's saying. That is the power product of powers. The product property of powers. When multiplying like bases, add the exponents. That's what you're going to do. So we're going to use that skill, that concept, to do many more questions as well. Now, when we're dividing, I already mentioned it earlier, that when you divide, you do the opposite. That you're going to end up doing the opposite. So it's literally going to be that when you see the shortcut. Take a look at the question on the bottom left. I'll call it question number 3. If you had 4x cubed, 4 times x to the third power is what that means. We have that times 2 times x to the second power. If you go to do questions like this, you're going to use the things you've learned in the past about multiplying constant numbers by a variable. For example, you've learned in the past that 2 times 3x, you've learned that equals 6x. That when multiplying, you don't need for them both to have the same variable. It's nice when they do, but it's not necessary. But essentially, the numbers always times each other. That's what you're going to be doing. So in number 3, let's start with the numbers, and then we'll work our way through the letters. In this case, we only have 1 letter in each. So let's start with the numbers. Multiplying. This says positive 4 times positive 2. Well, that gives us positive 8. So positive 4 times positive 2, that's positive 8. Now, for the x's, we have x to the third power times x to the second power. So if we're going to use our shortcut, we just told us when multiplying like bases, x and x, those are like bases, we have to add the exponents. So that means we have x and the power is going to be whatever 3 plus 2 is, since that exponent's a 3 and that exponent's a 2. So, and that gives us 5. So that tells us our answer is 8 times x to the 5th power. That is a simplified answer. That is a simplified version of number 3. That's as far as you can simplify it, given the information you have available to you at this time. Now we're using the product property of powers. Sometimes it's said slightly different. That's essentially the name of it. Now, what we're going to take a look at now is let's throw in some negatives. Let's throw in more letters, things like that. Let's try to make it a little bit tougher. So let's take a look at we'll call it question number 4. In this question, we're going to say, actually for the sake of, let me do one more simple example to make sure we're clear real fast. I want to remind you how we did up here when we had 2 to the second power times 2 to the third power. To show your work, you're essentially adding those exponents. The base is staying the same. Even if you know the bases, if they're the same, it stays the same. If you don't know the bases, because we don't know what x is, they still stay the same, and you just add the exponents. So you would have shown your work for this one up here by saying x to the 2 plus 3 power, and that's where the x to the 5th power came from. So I wanted you guys to see that down here. Oh, and coincidentally, I chose the same numbers down here. So that's how we do those. Now let's make a new one. All right, so in this example, we've got some negatives, we got some extra letters, because you can have more than one set of letters. You can technically have as many as it takes for the question. So now, just like last time, we're going to start with the numbers. We're going to start with the coefficients. So let's start from the front. Negative 6 times positive 3. Well, negative anything times positive anything is a negative. So we already know it's going to be negative. So now let's focus on 6 times 3. Well, that's 18. So it's just, in this case, it's negative 18 out front. So negative 18. Okay. Now let's move on to the letters. X to the 4th power times x to the 2nd power. That means to show our work, that means we know that we're going to add those powers together. That's what that tells us. And we'll figure out what that is in a minute. Well, I'm sure you already know x to the 6th power at this point. Now, y to the 3rd power times, oh, look at that. There's no y on the one on the right. So there's nothing to combine it with. So it's literally just, it gets stuck on the end. It's still there. Times y to the 3rd power is still there. It hasn't changed because there was nothing here that could change it. The only thing here that could change is if there was a y over here. So now right below that is where we now just say what we know it to equal. So negative 18x, x is to the 6th power now, and then y to the 3rd power. That's the fully simplified version of the original question. That's the fully simplified version. So now, take your time when it comes to multiplying things, because you add the exponents when multiplying. And remember, adding the exponents when multiplying. And you only add them when you have the same base. If you do not have the same base, like some examples we're going to do in a little bit, I'm starting out by showing a few examples. If you don't have the same base, you can't multiply them together. Now, if they're both numbers, like in this case, technically 3 is a base and 6 is a base. Technically 3 has an exponent of 1, technically 6 has an exponent of 1. But because the bases are different, but in this case we know what they are, we can just multiply them together. However, if this was a negative 6 and this was a negative 6, we would then have kept the negatives. We would have kept the 6 is what we would have done. We're now going to talk about some examples of dividing. Then we're just going to do some overall examples of both. Shoot through some examples to give you guys some feedback, and then we're going to be ready to move on. We'll do a couple word problems, and then we'll be all done. Okay, so keeping in mind what I said earlier about multiplying and dividing by the same thing, and how they cancel each other out, that's what we're going to use for a moment. Let's do an experiment. If we had, let's say, 2 times 2, all that divided by 2. Here we're multiplying by 2 and we're dividing by 2, and so they're the opposites of each other. They undo each other, so they cancel out. So if we cancel both of them, we're left with just 2 on the top. So the answer to this question is 2. Now if you did this the long way, we actually know these numbers. 2 times 2 is 4. 4 divided by 2 is 2. Okay, so that agrees. Now let's try another one. So 3 times 3 times 3 times 2 divided by 2 times 3 times 3. Now, if we were to do this, I see multiply by 2 and divided by 2 on the top and bottom, so those cancel. Now, I see times 3 and divided by 3 down at the bottom, so those cancel. Hey, why is that equal? Why is that all of a sudden eraser? Come back, 3. Don't be erased, just be crossed out. All right, so cancel, cancel. Now we have another divided by 3 and another times 3, so those cancel as well. So in this question, you look, you see, oh, I'm left with just a 3 up top. So that must mean the answer to my question is 3. And if you were to do this the long way, 3 times 3 is 9, 9 times 3 is 27, 27 times 2 is 54, 2 times 3 is 6, 6 times 3 is 18, so 54 divided by 18, oh, that is 3. So that agreed with what we knew it to be anyways. So these were examples using all numbers. So now notice, in each of them, the number of 2's in the top minus the number of 2's on the bottom is how many 2's we're left with. We had 2 2's on the top, we had 1 2 on the bottom, so 2 2's minus 1 2 equals 1 2. So that's why our answer is 2. And on this one, we had 2 3's on top minus the 2 3's on bottom, so we were still left with the third 3. Now, I think I said 2's on accident that time. I meant 3 3's minus 2 3's on the bottom leaves us with 1 3 still on top. And then we have 1 2 on top and 1 2 on bottom. So this 1 2 minus this 1 2 means no 2's. So no more 2's in our answer, so this equals 3. So that's what I mean. So the rule we're going to use for this one is when dividing, write it right here on the side, when dividing, I want to say when divide, like bases, so that could whether it be a letter or not. Like for example, up here, x cubed, x to the third power divided by x to the second power. We just said we're going to be subtracting. So the answer to that is x to the 1 power, which by the way is just x. So the answer to that random sample question I gave you, the answer is x. All right, anyway, so when dividing like bases, in that case like bases were x, in this case like bases were 2, and here we had like bases of 3 and 2. When dividing like bases, that's what it depends on. You subtract. You subtract their exponents. Always top minus the bottom. You blank, apparently I forgot the word subtract. So you subtract their exponents. You should write that down if you haven't written it down already. You subtract their exponents. Okay, I'm going to say x, and just stop at exponent. Okay, so exponents. So that's what we do for every single question. So now what we're going to do is let's come up with some examples for a moment. If you have, let's make up this question. Let's say k to the 9th power divided by k. Well, in this question, the top exponent's a 9. We don't see a bottom exponent. Well, we kind of need there to be one. So there technically is one. If you don't see one, that exponent is a 1. So really we have k to the 9th divided by k to the 1. So what we said was subtract their exponents. So 9 minus 1 is 8. So that tells us to show our work for this, the answer is k to the, 9 minus 1. The answer is k to the 8th power. That's the answer to that question. That's the simplified version. Now, if you did this visually, like how we were doing over here, if you were doing this visually, like how we did up here, you'd have 9 k's up top. You'd have 1 k on bottom. So the 1 k on bottom and one of the k's on top would cancel, and you'd be left with 8 k's on top. So that would tell us the answer is k to the 8th power. So that's how you could have done this question visually. Now, keep in mind, even if you have numbers, for example, I gotta make sure I throw in a number one to let you know, if you have common numbers, it still works. So 5 to the 3rd power divided by 5 to the 2nd power. That's not a good enough example. Let's say 5 to the 6th power up top. 5 to the 6th power divided by 5 to the 2nd power. You have common bases. The common base is 5, so you just have to subtract. 6 minus 2 is 4. So that means the answer to this question is 5 to the 4th power. And that's the simplified answer using exponents. Now if it said, what does it equal, meaning evaluate it, we could actually do 5 times 5 times 5 times 5 and see what that equals. But in this case, that's not necessary. We just wanted to see simplified with exponents. What does it give us? Okay, so in this example right here, we have negative 30 times y to the 4th power, all that divided by 5 times y to the 2nd power. So just like we mentioned over here when we were multiplying, we're going to go step by step, or we're going to start with the numbers, then we're going to go to the letters. So for this question, we start off with the numbers. Negative 30 divided by 5. Negative 30 divided by 5, a negative divided by a positive, well that's a negative. 30 divided by 5, that's 6. Now, y to the 4th power divided by y to the 2nd power, just like here. If the top one's a 4, the bottom one's a 2, we're going to do 4 minus 2 instead of 9 minus 1 in that last one. So 4 minus 2. Well, 4 minus 2 is 2, so that tells us it's y to the, we can actually show our work by doing, oh, I forgot the y. You can show your work by actually literally putting a y there and putting a 4 minus 2 right in there, and just say that that equals 6 times y to the 2nd power. Oh, and don't forget the negative. Negative 6 times y to the 2nd power. That's going to be the simplified version of that question. That is us simplifying exponents with division. Okay, ladies and gentlemen, so what we're going to do from here is we're going to run through a few examples rather quickly, some more simple examples, some harder examples, just to show you. Then we're going to do a couple word problems, and then we're going to be done. So at this point, if you haven't tried any of these on the screen thus far, for the rest of the questions you see coming up, you should be hitting pause, trying them first on your own, thinking to yourself, writing them down, and then hitting play and seeing how you're doing. I want you to actually do it and give yourself feedback, because actually trying it and checking yourself, getting feedback, remember that's practicing with purpose, that's how you're going to learn the most. Rather than saying, oh yeah, I could have done that, I'm sure I understood that, oh yeah, I got this. And so don't be so overconfident you don't actually try it. So prove it. Take a moment to see if you can do these next few questions without looking at examples. Alright, so try these 3 questions on the screen real fast. Hit pause and try these on your own, and then I'll go through and we'll knock these out really fast. I may not give a real detailed explanation, but I'll at least show you. Give these a shot. Alright, so make sure you hit pause. Now it's awkward. Hopefully you already hit pause and tried it. Okay, let's knock these out. All right, so the first one, a times a to the 4th. A doesn't have an exponent. We can give it an exponent. It's a 1. When you multiply, you add exponents. So that means these are common bases, so you add exponents. So 1 plus 4 is 5. So the answer to this question is a to the 5th power. That is the simplified answer for number 3. Number 5, start with the coefficients. They're different, so we're just going to go ahead and multiply these coefficients together. 3 times 4, that's 12. X to the, we just said first power if it doesn't have one, x to the first power times x to the 6th power, like bases, so we add the exponents. 1 plus 6, that's 7, so 12 times x to the 7th power. That's the answer to that number 5 on the screen. Now the number 7 on the screen, we have, let's start with the coefficients. This coefficient is a 6, this coefficient is a, I can't see it. So if it's not there, remember it's a 1. So that means in this case it's a negative 1. So I'm going to squeeze that in there. We have a negative 1 right there. So 6 times negative 1, a positive times a negative, that's going to give you a negative. So that's negative 6. K to the 5th times k to the 5th, that means we have k to the 5 plus 5, that's 10. So negative 6 times k to the 10th power. That's the answer to these questions. So these are examples of multiplying using the product property of exponents, of powers. Take a moment to think about those. Okay, try this number 9 one. And you're welcome to do number 7 too. But hit pause, try number 9. I'll even throw the answer number 7 up there. But I'm going to talk about number 9 first. First try number 7, I guess, then number 9. Hit pause. Okay, number 7, multiply the coefficients. So that 3 times 6 is 18. E to the 3rd times e to the 4th, that's e to the 7th. You're done with number 7. Number 9, this is a question I mentioned earlier to where I said if the coefficients were different, to just multiply them together. But if the coefficients are the same and our instructions tell us to simplify using exponents, we do not actually do 3 times 3. We're going to simplify using exponents. So this is 3 doesn't have an exponent, so he has an exponent of 1 because 3 to the first 1 power means 3 times nothing. It's literally just 3. He's not times anything because there's only 1 of him. So just equals 3. So that means we have 3 to the first power times 2 to the third power, just like it was if it was a variable. 1 plus 3 is 4, so that means we have a total of 3 to the 4th power. And if you were to do this one visually, if you were to do this question, you would have 1 3 on the left side, you'd have 5 u's on the left side. Now on the right side, you would have 3 3's. 1. Go away, eraser. 1, 2, 3. You'd have 8 u's. 1, 2, 3, 4, 5, 6, 7, 8. You have all of this, and in between you have times for all of those. So that's the visual way to lay this out. But let's see if we can do it without it. So now we have 3 to the 4th power. Now for our u's, u to the 5th times u to the 8th, they have like bases, add those. 5 times 8, that is 13. So it means we have u to the 13th power. So this is the simplified version of number 9 using the shortcuts. Now the visual way of doing this is how I wrote it up here. If you count, you have a total of 1, 2, 3, 4 3's. So that means 3 to the 4th power. If you count your u's, you have 5 over here, so 5, 6, 7, 8, 9, 10, 11, 12, 13. You have a total of 13 u's. So you have a total of u to the 13th power. So I just wanted you guys to see an example of multiplying even when your coefficients are the same. If they are and it says use exponents, make the coefficient have an exponent too. That is okay. Because by the way, if you just have this answer for number 7, e is to the 7th power. 18 is not to the 7th power. Only e has an exponent. 18 doesn't. His exponent is technically a 1. So I just want you guys to know that. Unless there's a parenthesis around the 18 and the e, unless it has that, it's just for the e. Okay, we're going to do 2 more multiplying examples, and then we're going to be done with multiplying examples. We'll do some dividing examples. All right, so look at number 8. Here, we have like bases. The like base is a fraction. Big deal. It's still a base because this whole thing is to the 2nd power. This whole thing is to the 3rd power. So they are like bases. So just because it's a fraction, it doesn't change anything. Use everything we've talked about, but just realize this is your base. So the base gets repeated just like before, 3 over 7. But now let's use the rule. When you multiply, remember we add the exponents. 2 plus 3, that's 5. So that means 3 over 7, all that to the 5th power. That's the answer to number 8. You're done. That's all you had to do for that question. Don't get freaked out because you see fractions. Yes, there's a way to see what this actually equals, but we don't care. The instructions said to find out what it equals using exponents. All right, number 10, knock through this one real fast because you had one just like it. Our coefficients are common, so that means we have a base, they're the same. So we're going to keep that 2, but we're going to do it to the 8 plus 8 power, so that's 16. So that means we have 2 to the 16th power. And then a is also a like basis for both of them. 5 plus 9 is 14. So a to the 14th power. So that's your fully simplified answer for number 10. We have 2 to the 16th power times a to the 14th power. That is the most simplest way to say that answer. Rather than figure out what is this giant number for the 2, what does that really equal times a to the 14th, we just simply leave it as an exponent. It's easier to say, it's easier to manage, and it's easier to calculate with. Now we're going to do some examples with dividing. If you think that you already understand how to do these, hit pause, try these 4 questions we have on the screen, give these questions a shot, and prove to yourself to see if you can do it. Okay, a to the 15th power over a to the 13th power. That tells us, we wrote earlier, when you divide with like bases, meaning these bases are like the same, you subtract their exponents. So that means 15 minus 13. So if you want to show your work as clearly as possible, you could actually write a to the 15th minus 13. Well, that equals a to the 2nd power. And you're done. That's the answer to number 18 on the screen. The number 20 on the screen, we've got coefficients. So let's do those first. We work our way through step by step. So 14 divided by 7, well that's 2. M cubed, m to the 3rd power divided by m. Remember that has a coefficient of 1 down there if you need it. 3 minus 1 is 2, so that means it's m to the 2nd power. So you're down with number 20. Number 20 is simplified. Number 22, 24 divided by 6, well that's just 4. T to the 10th divided by t to the 3rd, subtract, you have t to the 7th. And so that's going to be the simplified answer for number 22. Number 24, let's go ahead and do this one, and now let's do the same thing, let's subtract. So x to the 3rd power, and down here we have a like base, x to the, what power was that again? Well, if we just said the 1 power, the first power, so 3 minus 1, well, that's 2, so we have x to the second power. Now we have y to the fourth and y to the second. Subtract 4 minus 2, well, that's 2, so y to the second power. So that's our fully simplified answer for number 24. These are not like bases at this point, so we can't combine the x and the y anymore. We simply just do that. Some thoughts I want to share with you guys to make sure we're clear. When working with exponents and variables, I want you to know the only time you change your exponents or when you're multiplying and dividing. You never change your exponents when adding and subtracting. You only change them when multiplying and dividing. Because if you think about it, an exponent really means repeated multiplication. So you can't change that if all of a sudden you're going to start adding and subtracting. Because remember, multiplication is repeated addition. So because the exponent is repeated multiplication, we're not going to change the exponent whenever we add and subtract. Like let's say we had a squared plus a squared. That does not change the exponent. In fact, if we had a squared plus a squared, that would equal 2a squared. So we would change the coefficients with adding and subtracting, but we don't touch the exponent. So keep that in mind. Another thing to point out, notice when we divide, it isn't, let's do an easier example. And you're not dividing the exponents like 3. You don't do 3 divided by 1 for the exponents, because remember, exponents already represent repeated multiplication, and technically repeated division, so that's just the inverse. They represent that, so when you go to divide, you're already dividing or multiplying inside that exponent. You're not going to do it again to simplify. So think of it more as the visual way that we talked about when we showed, if we were to do this, if we were to do number 20 visually, for those of you who like the visual way, like let's say number 20, I see a 7 down here, so I'd like to see a 7 up here. So 14, that can be said as 2 times 7, and then m is just m times m times m. Okay, so I didn't mean for that eraser to pop up. Now on the bottom, we have 7 times m. This is the visual way of doing it. I see a 7 up top and a 7 on the bottom. Well, those cancel. I see an m on bottom, and I see at least divided by m on the bottom, and at least 1 multiplied by m on the top. So those cancel. So look what we're left with. Nothing left on the bottom, or technically it's 1. And on the top, we have 2 times m times m. Well, 2 times m times m, that's just 2 times m squared, or 2m squared. That's the same answer we got over here. So just know, yes, visually still works for these questions. It's a way to kind of explain them to help yourself see what cancels and what am I left with. So now what we're going to do, we're going to take a look at some word problems to help us see where some of this can be used. Up until now, we've been focusing on the calculations, the actual arithmetic of it. Now let's actually do a few word applied problems where you're solving questions with large numbers without actually having to use those large numbers. All right, so this is going to be our last 2 questions. So hit pause, try these questions first on your own and see how you're doing in order to work these out. Okay, so this first one, read to yourself as I read it out loud if you haven't done so already. It's about company bonuses. It says a company has set aside 10 to the 5th dollars for holiday employee bonuses. If the company has 10 to the 3rd employees and the money is divided equally among them, how many will each employee receive? Now this one might be a giveaway because they use the word divided. They might use the word split equally among them or allocated equally among them. That just means giving out, spreading out, dispersing among them equally. So just know, this one I agree was a giveaway. That might not always be the case. They're essentially saying, hey, you get $100. It's not 100. If you got $100, you give it to 10 people or giving it to 4 people. How much is each person getting? You would do $100 divided by 4 people. If you cut something into equal pieces, you know this is a division problem. So yes, we're going to divide. We're going to solve this question by division. So if it's not obvious, think about it yourself. Think of it as in a simpler example. What does that mean to you? How would you go about normally answering that? So okay, so we have 10 to the 5th dollars divided by 10 to the 3rd employees. So that's technically a rate, dollars per employee. We're not going to get into rates right now. So all we got to do is answer this. We're dividing, so we know we're going to subtract the exponents. So that means we're going to have a common base, like base is 10. 5 minus 3, well that's 10 to the 2nd power. But you're not going to walk up to somebody like, here's your 10 to the 2nd power bonus check. People are like, huh? What are you talking about? 10 to the 2nd what? And so be specific. This is a real life question. This is an applied question. So let's actually make it a real specific, applied, precise answer. 10 to the 2nd power. Let's actually see what it equals. Let's evaluate it. 10 to the 2nd power means 10 times 10. Well, that means 100. So that means we're talking money per person. So that means we're talking $100 per employee. for every employee, they're going to receive $100, or every employee is going to receive $100 as a bonus. That's the full, complete answer to this example. We'll call it number 1. Now, if you haven't already tried number 2, hit pause, give number 2 a shot yourself, but do the same thing. Show yourself what the exponent answer is, but then also make it a realistic answer. And I believe it's also about money, so make sure you're also talking dollars. Okay, car loans, read it out to yourself if you haven't done so already. After making a down payment, Mr. Green will make 7 to the second power monthly payments of 7 to the third power dollars each to pay for his new car. What is the total amount paid after the down payment? Let's do what I said earlier to make sure we understand what operation's happening here. If you're, let's say, paying $20 per month, and you're doing that for 40 months, that means $20 per month for 40 months. That means total, what are you going to have? 20 times 40? You're going to multiply them together to find that total amount, because it's 20 one month, 20 the next month, 20 the next month, so it's repeated addition. Well, remember, repeated addition is multiplying. So we know that this is a multiplying example. So I made up those numbers a second ago. Now let's actually use these numbers. 7 to the second power is how much he's paying monthly, and it said he's, it's how many months he's paying, and he is paying 7 to the third power each time. Let's find out what this equals. So 7 to the second power times 7 to the third, common basis, so we're multiplying, so we add the exponents. So that's going to be 7 to the 2 plus 3 power, which is just 7 to the 5th power. So that is the exponent answer. If it said express your answer as an exponent, you're done. That is your exponent answer, except this is a word problem. We're going to go further than that. That's not good enough, because you can't walk up and like, I'm going to take care of 7 to the 5th. Whoa, 7 to the 5th what? Whales, french fries? We don't know what that means. Let's be precise. Let's be specific. So 7 to the 5th power. This is where you grab your calculator and be very careful. And you're going to do 7 times 7 times 7 times 7 times 7. I think that was enough 7. 7 times 7 times 7 times 7 times 7. Okay? You end up with 16,807. Let's be specific. What is the total amount paid after the down payment? Meaning not considering the down payment. That tells us he's going to pay a grand total of, I forgot the dollar sign, we're talking money. He's going to pay a grand total of $16,000, well, $16,807. So include the dollar sign. That is the total he's going to pay even after his down payment. That's what he's paying for his car. So in this question, we were dealing with large numbers, but rather than dealing with 100,000 divided by, 1,000, we realized rather than doing 100,000 divided by 1,000, we were able to just use our exponent skills to get the correct answer. Rather than doing 49 times, well, whatever 49 times 7 is, whatever that is, rather than doing that big giant number, we're just going to go ahead and go to our answer by using our exponent skills and then evaluate that. So remember, it helps you simplify and deal with large situations. So good luck, guys.
Good afternoon.
All right, good luck and make sure you practice, guys.